Good afternoon, Year 11. Obviously, we're looking at a pre-recorded lesson today as I'm helping out with the key worker students in school. So I might not be immediately available if you do need a hand, but please pop me an email and I'll get back to you as soon as possible if you need help with any of this. So we've got our starter questions up on the board. Now remember that all of your work does need to be uploaded onto our team site in that OneNote exercise book. There was a video showing you how to do that if you were struggling. If you've got a massive problem with getting it online, then please send me a little screenshot of the problem you're having and we'll try and get that resolved, because we do need everyone being able to get their work uploaded so that we can have a good look at it and no one's falling behind, especially with the fact that we've got these teacher assessed grades. I want to be able to check off everything that we're doing for you so we can justify you getting the higher grades. Remember, Mr. Hayward also does have some laptops available in school, so if you are struggling and having a look on a little phone screen with this and don't have a larger device to have a look at the online lessons, then please get in touch with the school and we can sort you something out to help out there. Now, with a view to this being an online piece of work as well that does need to be submitted at some point, there's already a PDF version of this lesson plan that's in our Teams folder. So if you wanted to upload that and work straight on that for getting through these questions, then that'd be absolutely fantastic. And again, if you're working in your exercise book and uploading pictures, that's absolutely brilliant also. So having a look at the questions today, we've got 3 starter questions here to find the equation of the line between particular points. So if you'd like to have a go at those questions and then pause the video as soon as you're ready to go through the answers, then you can unpause and I'll run through them. So I'm going to assume that people are ready for going through the answers here, so I'm just going to skip over to those. So in the first question here, remember we need to find the gradient of these lines first. So we're looking for the change in y values here is 6, from 11 up to 17 is 6, and the change in the x values from 3 up to 5 is obviously 2. So we're looking at 6 over 2 for our gradient, which is 3. We then can start off our y equals 3x part. We wouldn't actually know about the plus 2 yet, but you can write the y equals 3x. To work out our plus 2, you actually need to kind of try out some values. Now, we did some substitution last lesson, but you might actually want to just kind of see what happens with the numbers straight away. And you might be able to work it out a little bit quicker using some methods now. So we know that this is actually telling us that the y value at the moment is 3 times the x value. But obviously we're going to need to do a little bit more than that. What you can do is just test that out with the coordinate. 3 times 3 is 9, not 11. And 3 times 5 is 15, not 17. So to actually get up to the numbers that we have got in our coordinates, we obviously need to be 2 more than the numbers we are working out at the moment, hence the plus 2 that we've got here. And of course you could write a full substitution for that, and it should be sufficient to do a mental calculation in order to find the plus c. Likewise, in the second question here, then we've gone down from 11 down to 5, so we've gone down by 6 for our y values, and x values here have gone from 6 down to 3, so we've gone down by 3 for our x values, and then that's given us minus 6 over minus 3. It's going to give us the equation there sorted, so we can get our gradient as 2. Sorry, my mouse just ran out of battery, so I was just plugging that in. So we're now looking at a gradient of 2, so you can write your y equals 2x part of your equation. Again, we don't know about the minus 1 just yet, but we can use that by testing out some numbers. If I do 6 times 2, I get 12, not 11. And if I do 3 times 2, I get 6 and not 5 that we're after. So you can see here that we do need to take away that 1. But of course, just like last lesson, if you wrote out a full substitution method, should be absolutely sufficient for you to be able to work out the constant term that we've got at the end. When we're looking down with our last number here, the last question, we've gone from minus 6 down to minus 21, so we've gone down by 15 in that case. And then from minus 1 to minus 5 with the x values, we've gone down by 4. Obviously our negatives cancel out again, and 15 over 4 gives us 3.75. This is where you're probably going to have a look at your calculator to help you out, although the first coordinate's quite easy to do mentally here as well. So what we're saying is to get our y value, you need to times your x value by 3.75. And then we need to work out what we've got left. So if you did minus 1 times 3.75, it would give us minus 3.75. And to get that all the way down to a 6, we're obviously going to need to take 2 1/4 away from it, 2.25, to get down to 6. And that you can check again with the -5 and -21 will work as well. So it is doable mentally, but you're probably going to have a calculator if you've seen that, because they're going to be testing your knowledge that you need to do the substitution or checking, rather than the fact that you can actually times something by 3.75 in the higher paper. So we need to know that parallel lines are ones that have the same gradient. We know that you can get lines, and if they run in the same direction, then those are going to be parallel. So if they're running in the same direction, they're obviously at the same angle. This means they have the same gradient. So this is the key to our parallel line knowledge. So if I said here, find a line parallel to y equals 3x plus 4, all we're after is absolutely any equation going that has the same gradient. We should know from our y equals mx plus c knowledge that the first number the coefficient of x, it doesn't need to be the first number, is the gradient. So we could have had something, remember, like y equals 4 plus 3x, and then it wouldn't have been the first number that explained the gradient. It would have been still the coefficient of x, the number in front of it. So that's a 3 here. So we're looking for any line equation where we've got a 3 in front of the x. Obviously we can only have one y in our equation, so y equals 3x plus 2 is going to be a line that's parallel to it. Y equals 3x plus 8, y equals 3x minus 2, y equals 3x plus a million. They're all going to be parallel. The ones that you might need to watch out for, we'll have a look at a little bit later. So find the line parallel to y equals 6x plus 2 that passes through the point 2, 10. So this is a little mix of a substitution question and a parallel line question. So find the line parallel to y equals 6x plus 2 that passes through a certain point. Well, we know that it's got to have the same gradient. So you can start off your line equation. It's got to have a gradient of 6 as well. So it's from y equals 6x. And again, now we're going to do that little bit of substitution, or even mental substitution like we did previously. What we're saying is to get our y value, we need to do 6 times our x value. Obviously that's not going to quite work at the moment with the two numbers that we have as our x and y value in the first coordinate here. So we know it has to pass through 2, 10, so we have to make this equation work and turn a 2 into a 10. We can't change the y, we can't change the 6x because we're told that it's parallel, so we know it's going to be 6x as the gradient. So we need to just write a plus or minus to complete this. So at the moment, if I did my x value times by 6, that's going to give us 12, not 10. So I know I'd need to take 2 away from that to make this line equation work. That's going to be how we find our full line equation for it. Now, ones to watch out for in this case that have tripped a few people up in the past, where we've got things like 2y plus 6x equals 4 as your equation. Remember that our y equals mx plus c is just that, it's a y equals equation. So you'd need to get y isolated on its own before you can do any more manipulation and treat that. So if I was going to find a line parallel to this, I'd need to do some rearrangements. First off, I need to make sure there's only one y in this. So we need to halve everything in the equation. Y equals 3x. Sorry, y plus 3x equals 2. I've halved everything in the equation there. And then you could move over your x to the other side of the equation. So it would be y equals minus 3x plus 2. Or you might see that written as y equals 2 minus 3x. And then we'd be able to write any line that's parallel to it. You can see clearly now that the gradient is minus 3. So we can write any equation that's got a y equals minus 3x in it. So minus 3x plus 100, minus 3x minus 2.875, whatever takes your fancy as long as it's not a plus 2. So watch out for those that did trip people up in the mock exam. Make sure you've only got one y before you start stating what the gradient of a line is. And it's just the other slide that had the answers on for those that are working ahead on the PDF. Perpendicular lines, these are really important. There's a few people mixing up parallel and perpendicular in the exam. So remember, parallel lines are exactly the same gradient. Perpendicular means that lines are at right angles, so at 90 degrees to each other. So if you've got two lines that meet in a square, those lines that meet are going to be perpendicular because they meet at a right angle. So perpendicular lines, there's 3 different ways of saying exactly the same thing here. Just to pick the one that you prefer. Perpendicular lines have a gradient that is the negative reciprocal of the original line. We know what negative means, and then reciprocal means flip it over as a fraction. The product of the gradients is also minus 1. So if you find a gradient and its perpendicular version of it, then you can times them together to get -1. That's a nice test if you're asked to prove that two lines are perpendicular. Maybe times the gradients together and show that it's -1. And then there's an algebraic way of writing that as well. If the first gradient is m, then the perpendicular gradient is -1 over m. And that's kind of just a rehash of the first one, the negative reciprocal of it. So this means that if you had a gradient of 3, then the perpendicular gradient is going to be -1 over 3. If you had a gradient of -6 even, then the perpendicular gradient to it is going to be a +1 over 6. If you already had a fraction, if you had 2/3 as your original gradient, then the perpendicular gradient to it is going to be a -3 over 2. You want to turn that into -1.5 or -1.5, but that should be absolutely sufficient for you to use some solutions to it. Or if you had a gradient of -2/7, then we're going to be having a look at the fact that your perpendicular gradient to be the negative version of that, i.e. a positive number, and flip over the fraction, so it'd be 7 over 2. And again, if you want to turn that into 3.5 or 3.5, that'd be great, but 7 over 2 should be sufficient for the rest of your questions. So if you can find a perpendicular gradient, we can then have a look at lines, obviously in more depth with this. So here we've got a question: find the gradient of a line perpendicular to the line y equals 3x plus 4. Look out for the little differences there. If you're looking at a line perpendicular, there's obviously going to be quite a few choices. If you're looking at the line perpendicular, look for a bit more information so that we've got a very specific line going on here. So find the gradient of a line perpendicular to the line y equals 3x plus 4. Well, the first thing to notice here is that our gradient of the line is 3. That's what we want to say. If you're talking about different gradients, you might want to put like M1 for gradient 1. Use a little subscript you see quite often there. So we're talking about that our gradient of the first line is 3, and then you could put maybe P for perpendicular, might be good notation to use. So the gradient of the perpendicular line is then going to be the negative reciprocal for that. So it's going to be negative, and if 3 over 1 would be 3 as a fraction, so it's going to be -1 over 3 when you flip that fraction over. So I've set -1/3 as our gradient for our perpendicular line. You can then start to write the line equation. So we can have y equals -1/3 -1/3 x minus x over 3 would work as well. And because it's any line perpendicular, we've got our choice of our c value at the end. So you can +2, +8, +1,000,000, or -2 even. Or I'm going to go for -3.621. So not being pernickety and putting a decimal in. It's still going to be a gradient perpendicular to it. Obviously, we've got a little step before. We've got the gradient first, and we found like any perpendicular line to it. Just a gradient is just our -1/3 is what we're after there for our final answer. We've just gone a little bit further and gone the route of getting the full line equation in. Find the gradient of a line perpendicular to the line y equals 0.5x minus 6. We're going to have the fact here that we obviously, given our first gradient is 0.5. So we're going to need to find a way of getting our perpendicular gradient there. So again, I'm going to put the fact that our first gradient, M1, equals 0.5. If you do negative reciprocal, you might find it easier to write it as the fraction at this point in the game. So 1 over 2. And then we can have our gradient of our perpendicular line. I want the subscript, sorry. And then we're going to find the negative reciprocal of that. So that's going to be -2 over 1, or just known as -2. That's going to be the gradient of our perpendicular line. So that would be our question answer, the gradient of the perpendicular line. Of course, now, if you were asked to write down any line that is there, you can start to put that into a line equation. We could say like y equals -2x plus 6, for example. As long as you've got the -2x there, we're clear on getting our line equation sorted. So you might be asked something a little bit more specific with these questions. So find the equation of the line perpendicular to y equals 2x plus 4 that passes through the point 4, 6. So we're kind of getting these substitution parts back in. So again, we're going to need our first gradient. You should be confident to read that straight from the line equation. Y equals 2x plus 4 has a gradient of 2. So we need our perpendicular gradient. And again, if our original gradient was 2, we're now looking for our perpendicular gradient to be a negative and the reciprocal of that, so negative 1 over 2. So minus 0.5. That might be another preference that people have. I know you guys seem to love decimals. I prefer to deal with the fractions because it makes some fraction questions easier. But if you want to deal with decimals, that's entirely up to you. So again, we can now start to write down our line equation here. So we're going to have y equals minus a half x plus something. We need to work out what that something is. Again, we've got a particular coordinate that this line must pass through, so the equation must make this work. We've got an x value of 4 and a y value of 6, so whatever our equation is, it must turn a 4 into a 6, because remember, it's telling us how to work out y if you know x. So we've got here then that our y value is negative a half of our x value plus c. So let's have a look. Again, some of you will be able to do this mentally, but let's pop the values in. So our y value of 6 must occur when we've got minus a half times x, so that's times 4, and plus whatever our c value is. Well, obviously a minus a half times 4 is minus 2. So then we should be able to work out what c is. Minus 2 plus c is 6, so c must be 8. And then we can plug that back into our original line equation that we started off here, because now we know what c is. So y equals minus a half x plus 8. We've got our line equation done for our perpendicular line. So that's a little run through of using our perpendicular lines. I've got one of our Corbett worksheets on our team site ready for us to have a look at. So again, with our Corbett worksheets, if you want to work through the question numbers for your progress, you don't need to do every single part as soon as you've grasped a question. Just make sure you do the last part of it, and then that should give you enough room to make lots of progress by moving through question numbers. Just to reiterate then, all of our work, remember, needs to be uploaded online so they can mark off that you've made this improvement with your mathematical work, and that'll look really good for your grades coming up. Please still pop and ask for help if you need to. It's red@theroyal.school for my email. And then I'll speak to you a little bit later. Now, I am going to upload an exam paper as well, because I think Century's down. If Century's up and running for you by the time the lesson ends, then the sort of lesson 1 maybe, then you can spend lesson 2 having a look at some Century work that I'm going to set. But as of this moment, which is 8 o'clock on Thursday night, then I've actually got the fact that Century's down, and we've had an email from them. So I'm going to also upload an exam paper for us to have a look at. I wouldn't expect people to be getting the exam paper completed during this session. Remember, you have like an hour and a half for the exam papers, and we've got like 50 minutes in a lesson. So you might want to try and get half of the exam paper done. Though, of course, if Century is up and running by Friday afternoon when you're doing this, by all means spend 50 minutes on Century for the second part of this lesson. So leave this over to you. Again, please get in touch if you do need any support, and I'll end the video now. Thank you very much. Have a lovely weekend and give yourselves a good pat on the back, because it's been a tough, weird week getting back in the swing of online learning. And I'll speak to you again next week. Thank you very much.